Hi again. It's time to do 8.2, where we're going to write confidence intervals to estimate proportions. So if you would open up your 8.2 day 1 blank notes so you can follow along and listen to the video. I also need you to open up the formula sheet. So that again is under classwork, chapter 8, formulas and tables, formula sheet 2020. All right, because we're going to be referring back to this in our lesson today. And today is the sad day where we would have flipped Hershey Kisses all over my classroom, but instead you have to imagine what that would look like. So we want to estimate what proportion of tosses will land flat. So if you were to take some Hershey Kisses, put them in a cup, shake them up, dump them out, some will land on their sides, some will land on their bottoms. What percent of the tosses will land flat? So I took 50 Hershey Kisses here at my house. I did not eat them all. And I tossed them and I calculated the proportion that landed flat. So let P hat be the proportion that did so. So my point estimate was 0.42. So I had 42% of my Hershey Kisses land on their bottoms. So then I don't know why this became so funkily formatted, but anyway, the population is all our Hershey Kisses. The parameter is the true proportion that actually lands. So if we were to take every Hershey Kiss in the land, put them in the biggest cup ever, shake them up, dump them over, the true proportion that they would land on their bottoms. So the sample would be our 50 Hershey Kisses. So P hat would be 0.42 for us. So was the sample random? And yes, if we were to just walk into a store and grab a bag of Hershey Kisses and then we were to just stick our hands in and draw 50 out, then that could be considered a random sample. So if you remember from chapter 4, the reason why choosing our sample at random, that means we get to generalize whatever we decide to the population as a whole. Now, the formula for calculating the standard deviation of the sampling distribution of P hat, that's what we learned in chapter 7. So this is actually found in your formula sheet on page 2 under part 3. So I'm going to click over to your formula sheet. I'm going to scroll down to page 2. Keep on keeping on. And you should see right here. This is where we're going to be flipping back and forth to. So when it asks for the standard deviation formula, it's sigma of P hat equals the square root of P times 1 minus P divided by the square root of, divided by N, all under the square root. So this is the formula for calculating the standard deviation of the sampling distribution. All right, so we learned back in chapter 7 that we can't use this formula because we are sampling without replacement. So independence has been violated. So the 10% condition has to be met in order to use the formula. And yes, 50% is less than 1/10 of all Hershey Kisses in the land. I think it's pretty safe to assume. Remember, 50 times 10 is 500. It's pretty safe to assume there's way more than 500 kisses. There might be 500 kisses in my cabinet. Anyway, so we don't know the value of P, right, y'all? That is the whole point of our confidence interval. We do not know this true proportion. So we're going to write an interval that we are going to be to some degree of confidence that this interval is going to capture this true proportion. So we have to use P hat instead of P. So you can see right here in this formula, it says that we're supposed to use P and 1 minus P, but we won't know the standard deviation because we don't have every single Hershey Kiss in the land. So we have to use P hat instead. So by taking and substituting in 0.42, because that was my P hat when I did my 50 Hershey Kisses, times 1 minus 0.42, divide that by 50, then take the square root. Our standard deviation is 0.0698 right here. So if you'll also notice, this is right here. And it's not called the standard deviation anymore. It's called the standard error of the sampling statistic. So because we are not going to know P, that's the whole reason we're writing a confidence interval, is so we can estimate the true proportion. We're going to have a sample proportion. So that's why the name changed. That's why it changed from the standard deviation to the standard error of the sampling statistic. Now, sometimes in AP stats, these two are used kind of interchangeably. Just remember, if you read standard error, that is the standard deviation. It's just you're using your sample statistic to calculate it, not the population parameter. So if I say standard deviation, I might mean standard error and vice versa. So you will be provided both of these in your formula sheet. All right. So then the next thing we have to check is, would it be appropriate to use the normal distribution? Because we're going to write a confidence interval. And if you remember from before, we have to get this margin of error. And to calculate this margin of error, we've got to know that the sampling distribution is normal. So if you remember from chapter 7, to see if we can use a normal distribution to model it, we have to check this large counts. So again, this is the counts of successes and failures. If you look at it like that, like that's another way you could write that we could use the normal distribution, is you don't have to call it large counts. You could just say, okay, we have 21 successes and 29 failures, and both of those values are greater than 10. So it would be appropriate to use a normal distribution. Or you can do n times p and n times 1 minus p. But remember, in this problem, we're not using p, we're using p hat. So n times p, n times 1 minus p. And we get 21 and 29. So yes, the normal condition has been met. So one of the reasons why the normal condition is important is because we learned from chapter 2 this thing called the empirical rule. And the empirical rule, if you remember, says that 95% of the data is going to be within 2 standard deviations of the mean. This is going to become very important in our construction of a confidence interval. In a normal distribution, 95% of the data lies within 2 standard deviations of the mean. This is going to be called our critical value. Now, we're going to have 2 ways to calculate our critical value. We're going to use table A, or we can use inverse norm to find these critical values. Now, if you have the fancy calculator, you can set the shaded region to be the center. So you just type in 0.8. Why did I put 0.8? I think that's supposed to be 0.95. That is not 80, unless I'm doing some. Oh, no, I know what I'm doing. I'm doing this one down here. 80% of the data lies within blank standard deviations of the mean. All right, so we learned 95% of the data from the empirical rule lies within 2 standard deviations of the mean. But what if I wanted to know how many standard deviations away from the mean 80% of the data lies within? That's not given to us by our empirical rule. So we have to find this value. So if you see the picture that I have right there, 80% is in the middle. So those 2 horizontal lines stand for the values of Z that will give us the appropriate shaded region. Now, if you have the fancy calculator, you can put 0.8001 and then click on the center. But if you have a regular calculator, you have to remember that the calculator does the area to the left of, so this will be negative Z right here. And so the calculator does the area to the left. So if we're doing an 80% interval, and 80% is in the middle, that gives us 20% in both of the tails. So this left tail is 10%. So to use your calculator, you can put 0.1, 0.01, and this will give you the value of Z. Now, using inverse norm, you're going to get the negative Z value, but remember, because your normal distribution is symmetric, then we will have whatever this negative Z is, that just is going to give you the number of standard deviations. So if you would grab a calculator, if you remember how to use the table, you can also use table A. So you could go here, you can scroll down to table A if my computer would cooperate right here, and we could find the tail probability at 0.1. It's down here somewhere. Most of you are going to grab your calculators. Please do. Type in and find 80% of the data lies within however many standard deviations. So I want you to practice using your calculator. I want you to try to find these numbers. 80% is going to be 1.282. So you know you're doing it right. And I can't write on this thing. Hee hee. So press pause and come back once you get these numbers. All right, let's see how you did. So 80% of the data, and there are the results. Now, I will want to point out to you that if you remember from the empirical rule, we said 95% of the data lies within 2 standard deviations of the mean. Well, if you notice right here that, yeah, we kind of lied to you. It's not exactly 2, but it's close enough. We're going to be using 1.96 for our critical value. Okay, so to kind of recap what you've done is, if you remember from the last lesson, 8.1, we talked about what a confidence level was. Now, you as a statistician will get to choose your level of confidence. For the AP exam, you're going to be given your level of confidence because we all want to get the same answer. So we need to find this critical value. We need to find the number of standard deviations away that this percent lies within. So this is going to help us calculate the margin of error. So the margin of error, we are now going to have a formula for. It's going to be 95%. You will take, calculate the margin of error for a 95% interval, multiplying the critical value and the standard deviation you found. So critical value for 95% is this 1.960. And then the standard deviation we found was right here, 0.0698. So we're going to multiply those together. That's your critical value times your standard deviation. That gives you your margin of error of 0.137. So to find the 95% confidence interval, we're going to take the 0.42. Remember, that was your point estimate, plus or minus your margin of error. So that gives you your confidence interval. Now, if we were all doing this together, we would have a nice graph. We would put intervals on the board, and hypothetically, each of you would have a different confidence interval. And if you were able to see everybody's confidence interval, it will look very similar to the applet we investigated in the last video. And then we would look at that and imagine where we think we would draw a vertical line through the 95% of the confidence intervals, and this would have landed around 0.35. That's a little bit anticlimactic since we can't really see everybody's, but that's the idea of 95% interval. So we are going to construct a confidence interval for P. Before we can construct a confidence interval, we must check that the 3 conditions are met. So a random sample must be used so we can generalize to the whole population. The 10% condition must be satisfied. This establishes independence, especially when we are sampling without replacement. We have to establish independence so we can calculate the standard error, which, remember, is interchangeable for the standard deviation. The normal condition has to be met. We have to check the large counts to see if we can use the normal distribution model for the situation. Here are 3 very commonly used values. Now, we are going to start calling these Z star because we are now looking at them as critical values. So this 1.645 is how many standard deviations away from the mean on either side. So we want to make sure that we know there's really 2 values, a positive and a negative. We just want to use the positive one. And we're going to now call these critical values Z star. And again, those are 3 very common ones that you will see. But you can also do any percent using inverse norm. You'll remember you'll put your tail probability always to the left unless you have the calculator where you can choose center. So your confidence interval is going to be your point estimate plus or minus your margin of error. We learned that in the last videos. Now that we have all of the information we need to calculate a confidence interval, to construct a confidence interval for proportions, we're going to put p hat plus or minus your critical value times your standard error. Let me show you what this looks like on the formula sheet. So if you go to your formula sheet back to page 1, it is under number 3. You have the format for a confidence interval. Now, if you'll notice, it's very generic because this is going to work for every type of confidence interval that we're going to write. Today, we're talking about proportions. So our statistic is p hat plus or minus our critical value. So now we know that the critical value is going to be called z star. This is going to be the number of standard deviations away from the true mean based on our confidence level. And then the standard error of the statistic, which we've discussed in detail. So this is like the formula, but you're not going to be given this formula specifically. You're going to be given that formula sheet with the words. So there is a check your understanding. I would like for you to try to complete this. Look at what we've done, think about it, and see if you have anything we need to clarify. So press pause until you're ready to discuss. All right, so your parameter of interest is going to be the proportion of all U.S. adults who often or always got enough sleep during the last 7 days. The conditions, a random sample of 1029 adults was selected. So check, this condition has been met. 10% condition, it is safe to assume that 1029 is less than 10% of all U.S. adults, so the 10% condition has been met. And then large counts is also met. So 1029 times your proportion, see that proportion right there, 48%. Both of these numbers are greater than 10. So we will be able to use the normal approximation of the sampling distribution. So you were then asked to find the critical value for 98%, which if you do like the yellow calculators in class is 0.01, because 98%, if we were to draw our picture, of course I can't draw with a mouse. So this is where the 98% would be in the middle. And we need to put that in the calculator, this area to the left. So 98% from 100, that means 2% are in the tails. So 1% is in this left tail. So you would type inverse norm 0.01, comma 01. Or if you have the fancy calculator, you can just put the 0.98 because that's our confidence level, 01 for the mean and the standard deviation. And then you know the 98% is in the center of the graph. And either way, you'll get the 2.326. So to calculate your confidence interval, you took your parameter, 0.48, plus or minus your critical value to 2.326 times the standard error. So remember, that's where we multiply 0.48 times 0.52, divide by 1029, and take the square root. There should be another parentheses here at the end. So we would get a margin of error of this 0.036. So add and subtract that to 0.48. So our confidence interval is from 0.444 to 0.516. This means we are 98% confident that the interval from 0.444 to 0.516 captures the true proportion of all U.S. adults who report that they often or always got enough sleep in the last week. All right, see you soon.